Okay. Alright, mic's on. Volume for the mic is on. Awesome. Alright, so to begin with, here's my map generator. Displacement size is pretty straightforward. This is actually an array, and this is the rows and columns that it generates when it goes. Game manager here. Just keeps track of player score. This decides what chips to generate. That's just the various speeds and levels and whatnot. That's supposed to be a variable between the ships, but this is the field of view for the enemies. Right now, the enemy ships kind of float off the map, but the AI is actually implemented, so it does the things it's supposed to. I just was more focused on getting the procedural generation working this go around and getting the pickups working. But I did throw in a couple nice little features for the pickups. Okay, so here you can see when the player ship rolls over the pickup, it actually picks up, and then it takes time to respawn, and it actually respawns a different type of pickup. So the first time it was just a permanent gain life pickup. This time it's the speed bonus. And the health pickup, the regular power-up pickup. The way I do it is that it can actually immediately regenerate a pickup if the pickup has been sitting there for a while. But if you quickly pick up 2 in a row, it'll take it longer to bring them back. And you can actually adjust the everything about the pickup values. And they do apply because the ship moves faster, even though with the current size of the rooms, I need to make the ship both smaller and slower, because otherwise it zips all the way across the screen. You can see the AI ships there floating in the background, and that's where I was talking about how I was more focused on getting the maze itself to work. But as you can see here, it uses 3 different types of room. It has the pickup room, it has a blank room with a regular square in the corner, and it has just a flat out blank room. And that's pretty much it. But it chooses between the 4 of those through the map generator here. And if we actually look at these rooms, you'll see that it has the power room, the spawning room, and everything else. And now I'll just go walking through the code real quick. So this is the procedural generation that I use. I use it as awake because I want to make sure it has created the I want to make sure that it has created the map before I start putting like the player ship or anything else on the map. Here's how it places the rooms. It generates them, it displaces them so that they don't overlap, and the displacement variable can be adjusted there. Fun fact, when you displace by Y, it actually goes up instead of out. It keeps screwing with me because whenever I think Y, I think out that way instead of up this way, but it's up this way. So when I was first displacing by Y instead of Z, like I am here, it was actually going upwards, which was fun. And yeah, other fun parts when you forget to iterate the row that you're currently working on, you end up putting everything in a single straight line, which is interesting because this never triggered. Door settings. The door settings just determine which doors to destroy, and that's kind of interesting because I actually just built on the room script that came with the the rooms themselves, which you can't see there because they're all attached to these. But that's neither here nor there. Ah. And you can pretty much change which room gets put where just by assigning them to the map generator list. So I was just doing that for debugging practices, but when it actually comes to the map generator itself, you can see by dragging in or by reassigning the rooms, you can actually make them come up with different variables. So you have these. This is the third one. And then these are the power-ups. And if I go ahead and zoom in here, you can see the 3 different power-ups. The temporary total health boost, the health recovery, and the speed booster. And you can see them all spawned independently of one another. So then when you're in this, well, you need to move the game so it picks up the input again. Still not really showing too much of the AI, but it's all wired up. It's just right now they're floating off the screen because I'm not properly implementing the player controller for them. But that's neither here nor there. I'm really just happy I got the procedural generation working. Okay, so back to code. Game Manager got a lot more complex. You can see that it now takes care of both the player spawn and the enemy spawn. And that's pretty simple. Like with... It'd be really hard to see, so I'll just show it. But with these, I have the spawn pedestal. The spawn pedestal is what actually produces the power-ups, and that's kind of interesting because when I go in here, you can see that it actually has a public void for someone ate it, which reduces the child object. It actually has a pointer for the child power-up that holds a container that points towards the child power-up. And when you go into one of the power-ups themselves, it has the pick up, rotate, and bob script, which was what you were seeing that was making the power-ups turn and bob up and down. That's one of the things that I added just for visual aesthetics. And then instead of having everything be able to do everything, I just have it so that it uses a switch statement in order to decide what it's assigned to do. And you can see that right here. This is neater because it allows for greater scalability and extension later on. Rather than having everything in a solid block of code, it has all of this written out in case statements so that it just can be plugged and played, pulled in, put out on the fly. And this makes life a good deal easier than having everything as a solid block of add this much to that. And then for everything else, you have the on-trigger exit. So it doesn't disappear when the player or the bad guy, which is the tag that the hostile ships use, first enter it, it actually triggers on the exit from it. So the player has to move into it and then move out of its collider in order to pick it up. And then it destroys it. But first it calls Tell My Parent I Love Them, which is from the spawning pedestal, which renders the pointer null. Because it'll actually render the pointer null here before it destroys it, so it's not pointing at a blank. And then it uses that logic for in order to spawn it again. The time.delta time that it uses for this, the way that I have it set up right now is that, and I can change it, but as it is right now, I could do it so that the time.delta time is down in here instead, because that would actually make more sense. And you can see the difference if I actually just do that right now. I mainly just had it outside there so that it would respawn quicker whenever the game was played. But to show you, and this is the way it's supposed to be, that it always triggers the refresh loop once it's been picked up. So it doesn't respawn until the timer has already been counted down, and it doesn't like stock up spawns as it was doing with the previous version that I had it. But yeah. So it calls this to decide what it's going to spawn. Decide what it's going to spawn does a roll in order to decide which power-up spawn choice it's going to make. And with all of my case statements, I always use defaults, because whenever you're doing the switches with their case, you always want it to have a default that it can fall back on. But that's really neither here nor there. For the power-up controller, and I have this on full screen right now, but for the power-up controller, it's very straightforward. It just does the assignment for what it is. It pushes back the public return for the instance of power-up that it gets, and it returns this power-up, and that attaches onto the player. The power creator here is very simple. Tank health is kind of interesting because I had to add additional extensibility to it in order to get it to work properly with the power-ups. And what that does is it'll actually pass it through the tank data in order to affect one of these. And then what it'll do is it will attempt to push to add the new health value. So that's what it does when it alters the tank health. It'll attempt to alter the tank health to add whatever the incoming integer is to this tank health. And this could also be used with a negative value. So if you put in a negative value here, it would add it to whatever the current value is, which is kind of cool. But it also has an overflow feature built into it. So if this tank health suddenly becomes more than this tank max health, then it knocks it back down to the max health instead of letting it go over, which is kind of cool because I also used that for the HP boost, because I didn't really agree with the way that it was written for the tutorial at the lecture that we got with this class, because with the health boost, when the health boost wore off of the original way that the first one was written, it would also take down the current tank health on top of taking down the maximum tank health. But with the way this one is written, is that when the boost falls off, it only removes the it only reduces the max tank health, and only then, if the current tank health is higher than the max tank health, does it reduce it. But otherwise, it leaves it alone. So if you pick up the HP boost and you're already at full HP, you get more HP, and then if you're still above that point, it goes back down to your regular HP. But if you pick up the HP boost and you lose HP to the point where you're not even at your original maximum, it doesn't put you down any further. It only puts you down further if you're over your original maximum, which is nice because it means you don't lose additional HP when the boost expires. That just kind of seemed counterintuitive to me. So the boost works really well for people who are at full health to get an additional temporary buffer of it. But it won't take them below. It won't take them any lower if they're below their original max health. But yeah, that's it's really straightforward. Because yeah, all it does is it resets the max tank health to whatever the new max tank health is, and that could be higher or lower. And you'll see it when I actually get into the like this one, and when I go into the power up, not the power up. No, it is the power up controller script. Okay, so I go into the power up controller script here, and you can see that I've set it up to be multi-layered, and yeah, so it just decides which one it is here, and then I actually have to go into the scripts here, and I have to pull up the actual power-up script itself, which is this one. And as you can see here, I used switch statements yet again, and the switch statements are speed boost, speed buff, health boost, health pickup, cash money. And what it does for that is that when it picks up, when it's attached to a script, and we have them here. So we have a private instance of this power-up, which is an inherited class of power-up, and it keeps it private. Then it does this dot power-up equals new power-up, and then it populates all of the various features of power-up, including power-up.effect type.speed boost, which allows us to designate what these are going to be in the instance of the class. And as you can see here, you have the various voids that will trigger on the target in order to affect the tank data that it's attached to, as it says here. And you'll see how it works like that. And then for the switch case, the switch just makes it point at the correct activation. But the activation is all accessed globally through the activate power and the deactivate power. So whenever you call the activate power or deactivate power, the only thing you're doing is triggering whatever it's already been set to. You're not actually able to assign what the power-up is or what the power-up's doing when you call the activate. So it's a very nice level of encapsulation because it's already been decided by the switch. So whenever it's being called by an outside entity, they're just hitting the activate power and the deactivate power. And I'll go through this a bit more, but as you can see, I made a lot of my up top variables private, if they did not need to absolutely be accessed by something outside. The map maker, it's all public because it needs to be manipulated. The tank controller, pawn's private. The tank health, all that's pretty much private. The game manager itself is where most of my public stuff goes, except for the stuff that's controlled by the given instance of the game manager itself, which is going to be the spawns and the map, because it keeps a private instance of the map in order to be able to point at it. And this is important later on because it uses the map in order to identify the various spawn locations for both the player and the enemies. They actually use the same spawn locations. It's just that since there's a spawn location in every square, they're all over the place, literally. But yeah, so I'm going to spend a bit more time going over the map maker here, since that's the major point of this one, or one of the two, other than the power-ups. So what this does is, I already know how to use an array I already know how to use array in the inspector window. It's not terribly hard, and I can change it later, but I keep the array public for some of the stuff in order to make it easier for the designer to deal with the seed. Because the unique way that I actually tackled the seed was that in the map generator here, you have the seed number, and the seed number is actually an array of integers. And you can actually go down through this entire list, and you can change which number is where in the array. And this is very convenient rather than using a flat-out integer or using some kind of complex division scheme, because you can put in by hand which numbers are going to be in here, and then it'll iterate through it. So you have even more control over the seed than you would if you were just using, say, a division. Because even though it seems random, it's not. And sometimes designer random is better than numerical random because it allows for a greater degree of control over the interconnections of it. And since it's a scalable array, you can literally make it as long as you can pretty much fit on the computer. And it doesn't take up as much processing time as looking up an array, looking up an integer in an array as it would to run the calculation process to come up with the number, to then push it into the array, to then do the loops through it and whatnot. Base by day, I actually have this on by default just because I choose to have it on, because otherwise you would start by using the on number 5. But as you can see, if base by day is on, it overrides that. So instead of having on number equal to what you originally assigned it in, as in the inspector, it becomes the day of the week. So day of the week equals day of the week WK equals date time dot today dot day of the week. So day of the week is just the enumeration that returns the number, and then we use convert to turn the enumeration into an integer to use it for the starting location for the array. Alright, I said that right. And then it goes down and it starts going through that. And what it does is it'll just iterate through it in order to choose which room is going to be where. And if the odd number gets larger than the maximum length of the seed number, it goes back to 0 on the array length so that it returns properly. And that's all really choose room does, is it just goes through the array repeatedly in order to come up with what the various seed numbers are going to be. And then the seed number chooses the room, and then the room gets added to the array. Let's go take a real quick peek back at that again. And this is blank right now because it hasn't started, but if we hit play, you can see that it goes ahead and fills in this list. And it fills in this list with the number of elements necessary to actually fulfill the array size. But that's really neither here nor there. So what this does is it adds them to the array. Actually, these get added to list. Yeah, these get added to list because list has a greater dynamic size than the array. And then this actually prints them out. And I'll just go over this really quick because then we'll actually look at the room script. But as it is right here, you have the placement location reset for the x-axis. You have the placement increment for the displacement size whenever it maxes out the row number. So it returns like a typewriter and starts again. And then you have the placement location displacement addition for the x. So this is as if you're like typing on a typewriter, this would be the typewriter chicking over to the left as you type on it so that you stayed center, but your words are actually going to the right on the page. The vector math and the dislocation stuff is fun. Vector math is always fun. But this helps it type across the page so that it gets to the location you want it to be. And then all this does is it's calling our rooms and is telling us which set of doors should be closed. So room is the class, door switch is the enumerator, and then center would be what type of room it is, west would be what type of room it is, east would be what type of room it is. And as it's going through these, it's just making sure that the proper doors are open, i.e. destroyed, so that the player can move room to room. As it sits right now, the way that I'm dealing with the character controller, I actually have gravity off, but it's kind of hilarious if I just go in and turn on gravity. Because if I go into my prefabs here and I select my ship, and since now I have a floor for everything, for my character controller, it's not showing. Oh well, I guess I don't need to worry about gravity. I don't have a rigid two-body attached to it, so I don't have to worry about things falling. Even though I think character controller has gravity in it, but well, neither here nor there. But that's okay. I just don't have gravity on them right now, but that's not a terribly huge problem. But yeah. Okay, so with these we have the door getting turned on and off, and that's pretty simple. Then after it fills in the object and describes how it's going to be, where it's going to be, I actually have it instantiated here. So this is what actually creates the room, and it pushes it into the list for these rooms, because these rooms X isn't real until it actually gets instantiated. So it's an abstract existence because it gets assigned a prefab up here when it gets pushed into here. So when it's running through place rooms, it's taking the abstract of add room. It's choosing which number it's getting. It's going to add room to actually add the room to the these rooms list. And then when it gets down to here with the place room, it's actually running through the these rooms list in order to set their location and then to instantiate them. So they're not actually, they don't exist in the game world until we hit this point. And then the doors are opened at this point. And then it iterates so it can get through the list. But yeah, that's pretty much right smack on top of everything for it. And the room rows, the room columns, I use range in order to keep it from getting ridiculous, since I'm using a list in order to hold the game objects instead of like a graph node, which has a lot more flexibility for procedural generation than using a list. Because with lists the way it is right now, it would be 20 to the power of 20 in complexity in order to navigate through it, even just in a regular iteration. It's not super intense with this one because I'm just going through it one way twice rather than going through it multiple times in order to add to the end of it. But I typically wouldn't want to use this method to generate significantly sized rooms or rooms with more information on them than typical, simply because lists aren't very efficient for mapping stuff, and I definitely wouldn't want to use a list for really truly great AI pathfinding, because with the way that I have this working right now, if I had, say, 4,000 rooms by 4,000 rooms, we'd be here for a small eternity just waiting for the umpteen thousand, 100 million something rooms to process and for it to run through the entire process of creating all of them, which normally you shouldn't have a terribly tough time doing. It's just using a list to do it would be extremely inefficient. And it would be monstrously even more inefficient to attempt to map all of the rooms themselves. As you can see here, because with my waypoints, you can see that most rooms actually contain at least 5 waypoints, with the exception of room variant, which contains one, two, three, four. No, this one. This one actually contains 1, 2, 3, 4, 5, 6, 7 different waypoints to it. So if I had even 700 of these, it would be 49,000 waypoints that it would have to map, and it wouldn't be able to realize the closeness of any given node just on the basis of where that node rests inside of the node graph. So it would have to find not only the distance between those, but the distance between these physical entities themselves, whereas which if I was doing a node graph, I could just go ahead and automatically create a super map on top of everything else so that the rooms know where each other are from the get-go. And as you can see here, I actually did a super type. So I have the base room prefab, and then I have a super prefab on top of that, which makes my life a little bit easier when it comes to dealing with them. But that's really neither here nor there. But yeah, so here's my here's the map maker class, and it has mono behavior. It actually does the same public static thing that the game manager does. It makes the class itself visible to all the other ones. Comment-wise, this is very simple, because add rooms. And since I did integer lists instead of using it as a single integer, I could actually have upwards of 100 different types of rooms that I could spawn. So, I mean, technically, even though all programming is an abstract science, when I say it adds them to the list as an abstract, it adds a preconception of the prefab to the list before changing its starting specifics and spawning it, which is the way that I go about actually making it a reality. Because I guess theoretically I could instantiate it, then move it, but that just kind of seems like a hassle and could cause quite a few problems. So I just instantiate it in the spot that it needs to be after deciding where it's supposed to go, up here. But that's just me. Nothing really new to see on any of the tank health, tank controller, or pretty much anything else in that matter. But yeah, since the pickup of the since the pickup of the power-up is actually handled by tank data, and since both the player ship and the enemy ship are using tank data, because data is the central part of its controller, we have the add power-up here. And when it does the add power-up, you can see if it's not permanent, then it goes ahead and adds it to the list in order to check as it's running through it. So you can see the whole update expired power-ups thing running through here, and then it iterates through the list in order to check to see which of the power-ups are working and not working. And just because I am kind of untrusting, I have tries and catches in there, even though I clear the list every time. I want to make sure I don't accidentally do something that could cause a significant problem with trying to remove something from a blank list. But I mean, with the 4 each, it typically shouldn't enter in if there wasn't one in there to begin with, because the 4 each will just skip over the list if there's nothing in it. This is just the pass-throughs for the add ship health, the add ship total health, the add ship speed that I use in order to trigger the other handlers in it, because those just will point straight over here. And with the tank controller is actually just handled in the tank data. It's not the tank controller. The adding the speed is just handled directly by the tank data itself, because the tank data has to hold it for the pawn, and it just updates and increments and decrements the turn speed and move speed. So that's how I implement the powers for the ship. And this actually determines what the ship is, what stats it has. It's how it pulls it from the game manager. And as you can see, it's clearly enumerated underneath the ship types, since we have a finite state in order to decide what types of ships we have. Because in order to make this a controller that works just as well on any other ship type, I just have to add the enumeration up here, and then add its consistent block of code down here. And that's pretty much all it has to do, which makes life very simple for me if I want to increase the number of enemies that I have. Because, like, yeah, right here, this passes the new ship speed, and whenever it increments or decrements from the power-ups, as you can see here, deactivate, on deactivate, 2 switch statements, on activate, on activate, on deactivate, calls the relevant equivalent private function, well, a private method within the power-up class itself in order to trigger or deactivate the effect. But that's pretty much it. So, going through this for a little bit more of a playthrough. The unique features that I kind of did for this one were the whole spin and rotate for the power-up boxes, the 3 different types of power-ups for the scene. I didn't really do anything unique with the procedural generation. It's just I made sure to make it scalable so that you could actually increase or decrease the number of types of rooms you have and the number of rooms you can use. I'll just go real quickly over here to show that the map actually does build to a different size. So you go over to the scene here, and you can see that it does build correctly when you readjust the size. But yeah, that's the way it works. And when I tell it to spawn multiple enemies, that's actually controllable by the slider. The requirement's called for 4, but with the game manager here, I can actually turn that up to 6 or down to 0 or any real number in between, and that can be changed by modifying the range in the actual class itself. So it gives me a bit more control as the programmer over what the minimum range, the maximum range are, just to prevent issues like divide by 0, multiply by 0, because that can cause a lot of headaches down the line. So this just gives, putting in those sliders just gives me a way to do better control over inputs, which is nice. But aside from that, all this really does is it makes sure that I spawn the player if the player doesn't exist, and I spawn the hostiles when I first start up the map. As of right now, since I've already demonstrated it with the power-ups, I could just include a message back to the game manager to respawn enemies or to increment the number of enemies when enemies are destroyed, but I just haven't rolled that out yet because I still haven't fully implemented the AI. but that's because I'm going to spend this next week doing graph nodes so that I can actually have them move correctly between rooms, not just within the room that they belong in. So let's just take a very quick peek at the AI controller as it exists now. So you see more enumerators, you see waypoint sets. This has actually been removed from the previous version. Even though we have the various previous set of loop types, I still want to replace the simpler one and implement this one, which is going to allow the AI itself to pull a path from the map in order to come up with a set of waypoints using a node graph system instead of using just the find the closest, although I have implemented the find the closest. And here you can see my very simple cut down AI code, because like with this one, shoots at the player when they get close. So with the here player, all the here player is going to do is it's going to check to see if the player is within hearing range, and if they're not, then it goes to the Johnny Football Helmet mindset, which just tells it to follow waypoints. And that just goes down the line and attempts to see it. Otherwise, it'll just toggle back and forth between Johnny Football Helmet and Hostile Gunner. The Suicide Runner, it just tries to run at the player. If it can hear the player, it chases him. That's it. And the whole purpose to that is trying to get it to run into the player and do a one-hit kill. Dive Bomber is kind of interesting in the fact that it checks to do avoidance to see if there's obstacles in the way, and then if there aren't, they're not, it does the shell dive bomb, which tells it to chase the player, and then it tries to do some shooting. So since shell dive bomb should be lining it up with the player, it should be trying to shoot at the player as it's approaching the player. And if it's too close to the player, which you will see the logic in the shell dive bombing, it will actually attempt to run away from the player, which is kind of funny because it'll switch to the begin fleeing. And then you have the Fire Bad. Johnny Football Helmet just really does the case for Johnny Football Helmet really just follows waypoints, and then if it runs out of waypoints, it just switches to Hostile Gunner. The AI behavior choice .fire bad, it does avoidance or it flees. And of course, if it can't decide what state it's in, it just reverts back to Johnny Football Helmet. And here you can actually see that if its HP is less than or equal to 2, it will change its current AI choice to Fire Bad, which just sends it up into here. So it starts running away because its health is low. It's very straightforward. Begin fleeing, find the unblocked vector path. It just looks for the unblocked vector path. If it can find the unblocked vector path, then it goes ahead and chooses that path, and it uses that to run away. So here's all the progressing for the waypoints, and when this is updated so that it goes through the waypoint list and chooses the waypoints that it needs to do, it will actually go ahead and pull the waypoints that it needs after I get done with the node path. Because the way the node path is supposed to work is it's supposed to use recursion. The way that I want it to work is it's supposed to find the closest waypoint to it. Then it's supposed to use recursion in order to find 8 connecting waypoints from it. And then when it gets to that last eighth one, it's supposed to double back and do it again. And the way that it's supposed to work is you're supposed to have the graph nodes. So you have, or the node graph, so you have the node that you're currently on, which is the waypoint that's closest. Then you have the edges for that, which are all the waypoints that connect to it. And then what it's supposed to do is it's supposed to look at all the edges that are connected to that node, i.e. that waypoint that it's nearest to, and then it's supposed to find the edges that lead to the next waypoints. And the node itself on the node graph knows where the edges are, and the edges point towards waypoints that are near that waypoint itself. So rather than going through an entire list that just returns the tag waypoint, you go through the graph, you ping the graph, you pull the node, the waypoint, and then you pull the waypoint's edges. So after you've identified your starting point, then you're supposed to pull the edges from it in order to get your next set of waypoints, or your next waypoint. So you take the waypoint that you're currently on, and then you point it towards, you choose an edge, and you follow that edge to the next waypoint, and then you pull the edges from that waypoint. The only thing that I'll have to do is I'll have to keep track of what the previous waypoint was, so that it doesn't just go back and forth repeatedly. Because while that is possible, I would like it to choose something that is not the waypoint that it already came from. So I'm not going to make my node graph monodirectional, but I'm going to put in something there for the recursion to prevent it from going back to the previous waypoint unless that's the only waypoint that exists. Because if it tries to go to, say, one of the waypoints that's at like the edge of the door that's closed, so it can't go off like the north side of the map, but I want it to be so once it gets to that waypoint, there should be at least 2 other waypoints connected to it, but if there isn't, that it's able to go back to the waypoint it just came from. And the hope is that with that, I should be able to keep it from getting stuck in a corner, and it will be significantly less processor intensive than pulling the entire list, pulling everything to see how close it is to itself. So I'll probably use Jastroyskis in order to, when I get advanced enough to the point where I want to tell it to go to the other side of the map, I should be able to, with the implementation of the node graph, I should be able to tell something to go to the other side of the map, and Jastroyskis will find the shortest path there by traversing the node graph. And the best way for me to do that would to, when I generate the map, then I generate the node graph for the map off the waypoints, and I use the wondrous square dot difference, the float difference dot diff dot square magnitude, in order to find the actual distance between the waypoints and then assign that as the weight value to the edge, so that when Jastroyskis is working through the node graph, that it's able to properly and effectively use the weight of the distance between the 2 points in order to effectively determine the most efficient travel direction for the path. At least that's the hope. Because when you use Jastroyskis, you should be able to do it. And I mean, an even more advanced application would be if you had like a dynamic landscape, you could do raycast between the 2 points in order to find out if something is blocked. Or when you do one of the path smoothings, you could actually do the raycast then if there seems to be a problem, because it should, if an agent is attempting to move through a maze, but there's another agent that's blocking its way, it should be able to tell that there's an agent blocking its way and not continually attempt to go through the path. Or it could regress to the previous point if another agent pushed it into, say, a corner. And that's some of the more advanced stuff that you see in the book. But yeah, I focused on the procedural generation, the power-ups, the power-up pickups, getting everything to talk to itself. So the AI kind of suffered in this one, even though I finished implementing the actual finite state logic for it. I did not finish implementing the waypoint following for it. So even though it can see everything, hear everything, turn towards it and shoot at it like it was doing previously, We are currently not traveling waypoints just because I've held off on putting those in and kind of triaged in order to get the procedural generation, the power-ups, the power-up pickups, the updates, the other mechanics of the system working. And I've just kind of shot myself in the foot trying to get everything else done other than the AI. But I'm actually quite happy with the amount of work that I got done with the game itself. So, that's my presentation. Thank you for watching.